So in our discussion today, we are going to look at concepts under what we are calling as being electricity. So that's the discussion that we are going to look at. So concept under electricity that you need to remember. Now, of course, we are just going to put up important concept to help you, especially with the upcoming exams that are coming. So what exactly is electricity? Well, you can define electricity as simply the flow of electric current. So you can simply define electricity, we can say, is the flow of electric, so the flow of electric current, so the flow of electric current in a conductor. So whenever an electric current flows in a conductor, we can say that is electricity. So this brings us now to what we are calling as being what is an electric current. So electric current is represented by I. So what is exactly electric current? Well, electric current, we can simply say, is the flow of charge per unit time. So we can say is the flow of charge, so the flow of charge per unit time. So the flow of charge per unit time, that is what we can simply call as being electric current. Or we can simply define it and simply say electric current is the rate of flow, so the rate of flow of charge. So the rate of flow of charge. Remember, when we use the word rate, it actually entails time. So there's no need of you putting time again, because you have actually used the word rate. So it is the rate of flow of charge. And therefore, we can come up with a formula in this case for electric current. We can simply say, from the first definition, electric current is the flow of charge per unit time, and therefore we can simply say that this electric current I is simply going to be given by charge, represented by that symbol, divided by what we are calling as being time, represented by small letter t. So in simple terms, that is, we can say electric current I is equal to charge divided by time. And this is the formula that we are going to be using to calculate what we are calling as being electric current. But the question that you may have is that what is the SI unit for electric current? Well, electric current is actually measured in ampere. It is measured in ampere, represented by capital letter S. Some people abbreviate it and say amps, but we still use capital letter S. So that's the SI unit. But sometimes in the exam, you may not find that they may give you ampere. But if you remember, charge is measured in coulombs, represented by capital letter C, and your time is measured in actually seconds. So that C is representing coulombs, the unit for charge, coulombs, and that S is representing seconds. So if you combine coulombs and second, you're going to have coulomb per second. That's another unit we can say for electric current. Therefore, I can simply say, what is the relationship between ampere and coulomb per second? Well, the relationship is simple. 1 ampere is equal to 1 coulomb per second. So that is the relationship that exists. Another concept that you need to remember is that electric current is measured using an instrument called an ammeter. So instrument, so we can simply say instrument used for measuring. So instrument used for measuring electric current. So the instrument used for measuring electric current is called an ammeter. So we use the word, we use an ammeter. And what's the circuit symbol? Well, the circuit symbol that we use for an ammeter the circuit symbol that we use, you'll be able to see a capital letter A, and that's the circuit symbol for an ammeter. So that's the positive terminal and the negative terminal. In most cases, the positive terminal is red and the negative terminal is actually black. So the way it is that an ammeter is always connected in series to the component to be measured. I'll show you in just a short while. The negative terminal is connected to the negative terminal of the battery, and the positive terminal is also connected to the positive terminal of the battery. So what do I mean when I say an ammeter is always connected in series? Let's just flip and put up. So we can simply say, you know, ammeter is always connected. It is always connected in series. So it is always connected in series to the component that you are measuring. For example, if this is a power source that I'm having, if this is the power source that I'm having there, it simply means I can put up an ammeter there, but that ammeter should always be in series to the component that you are measuring. So imagine that this is a bulb and you're trying to measure the current passing through the bulb. It simply means that your ammeter there is actually connected in series. When we say in series, they are actually in the same line. They are not branching anyhow. Now, when it comes to a cell, this is what we are calling as being a cell. The longer part is considered positive and the shorter part is considered positive. So we call that one as being a cell. But if you take two or more cells and actually put them together, they make up what we call as being a battery. The longest side will still be positive and the other side will still be a negative. So according to what we know, electric current actually moves from positive to negative. So the flow, so that is indicating the flow of current, which we simply call as being conventional, you know, current. And from negative to positive, this indicates the flow of electrons. So we can say flow of E minus, that is the flow of electrons. Electrons move from negative to positive. In fact, the flow of the conventional current is opposite to the flow of electrons. So that is what you need to be remembering. We'll move on to another concept that we are simply talking about, which we simply call as being potential difference. Potential difference, you know, PD, as we may call it. Well, potential difference, how can we define potential difference? Well, let me give you something. Imagine that you do have what we are calling as being, maybe before we can even talk about potential difference, let me just talk about a few concepts that I've highlighted. Suppose you want to find, you know, charge. What are you going to do? Let's focus on what we are calling as being charge. Well, what exactly is charge? Well, charge indicates the number of electrons that are passing a point in a unit time. For example, if I've got a conductor like a wire like here, and of course we know electrons are going to be moving along this conductor. Let's say I've got a point here I'm calling A. How many electrons are passing this point in a unit time? That is what we simply call as being charge. So charge is the number, we can simply say, is the number of electrons, passing, you know, passing a point per unit charge. That's what we call as being, you know, charge. So the number of electrons passing a point per unit, sorry, not per unit, you know, charge, but per unit time. And therefore, from the formula that we established there, which we said current is equal to charge divided by time, if we make charge the subject of the formula by saying over 1 and cross multiplying, therefore our charge will be equal to IT, current times time. Now if you remember the relationship that is there, charge is measured in coulombs, current is measured in amperes, multiply time is measured in seconds. So what's the relationship between Coulomb and, you know, ampere second? Well, we know that 1 Coulomb is equal to 1 ampere second. That's what we know, 1 as. That's what we mean. Remember, the SI unit in this case for a charge is simply coulombs, and this is the formula that we apply in order to find what we are calling as being, you know, charge. So charge is equal to current multiply by time. I hope you got you know, the concept. So in my next discussion, what we are going to do is that I will look at some practice questions. But before I conclude, I want to tell you something. What is a Coulomb? Well, we can go back and try to clean up you know, this section of the board so that we talk about exactly 1 Coulomb. So if you're doing a pure science, you know, this concept is very important, you know, for you. In this case, we can simply say that you know, 1 Coulomb, we can say 1 Coulomb, that's 1 Coulomb. We can simply say 1 Coulomb, you know, is the charge. 1 Coulomb is the charge, you know, carried by 6.25 times 10 raised to the power 18 electrons. So that's what we can say 1 Coulomb is. So it is the charge carried by, you know, 6.25 times 10 raised to the power 18 electrons. What do I mean? Well, mathematically we can try to express it and say 1 Coulomb is equal to 6.25 times 10 raised to the power 18 electrons. So in 1 Coulomb there are this number of electrons that we can have. But sometimes you would love to know what 1 electron is there. So what we can do, we can simply say, since 1 Coulomb is equal to 6.25 times 10 raised to the power 18 electrons, I can say, what about for 1 electron, then what is the charge carried by that 1 electron? So we can cross multiply, and when we cross multiply, it will be x multiplied by 6.25 times 10 raised to the power 18 is equal to 1 times 1 will give me a 1. To find x, I'll divide 6.25 times 10 to the power 18. What you do this side, you also do it the other side. Of course, this and that will cancel, I'll remain with just x. If you type in, key in this value on your calculator, 1 divided by, you know, 6.25 exponential, you know, 18, it is giving me 1.6 times 10 raised to the power negative 19 coulombs. In simple terms, we mean that 1 electron carries a charge of 1.6 times 10 raised to the power negative 19 coulombs. So this concept here becomes very important, and that concept there becomes very important if you are doing pure sciences, because we are going to be using these two expressions. See you in my next videos when we look at you know, some questions on how you can use the formula for electric current and also, you know, charge.